Right, hi there. Today we're going to look at using trigonometry and SOHCAHTOA in a right angle triangle to work out an angle. Right, in this case, in this diagram, this angle here represents the angle of elevation from the person looking to the top of the Eiffel Tower. As always with using SOHCAHTOA and trigonometry in a right angle triangle, the first thing we have to do is label the sides. Now, the longest side is called the hypotenuse, as we know, and this is the longest side. I know that because, one, it looks the longest, even though it's not drawn to scale, because it's opposite the right angle. Okay, the hypotenuse is always opposite the right angle. So that is H. I'm going to label that H. This side here, which is part of the Eiffel Tower, is the opposite side because it is opposite the angle that we are asked to find. So the opposite side is always opposite the angle we're asked to find, or the angle we're given, if we're using trigonometry to find a length. So this is O. And then the other one is obviously A, the adjacent side. And that's the side next to our angle, because adjacent means next to. Okay, now we've labelled the sides. The next thing we need to do is write our word SOHCAHTOA in our trusty 3 triangles. Now we can use these triangles for any 3-part formula, like we do with speed, distance and time, mass, density, volume. You could use it for circumference equals pi d, any 3-part formula. And like I've said before, they are a bit of a cheat because you should be able to rearrange these formula without using these triangles. But having said that, they do provide a nice visual picture to help us choose the right formula and to help us work out our answer. Now our next step then is, after we've labelled our sides and written SOHCAHTOA in our triangles, SOHCAHTOA, we tick the sides we are given. So we need to tick 2 sides, because if we find an angle, that's associated with the sine, cos or the tan. So if you're going to work out the sine, cos or the tan part of these triangles, you need the other 2 sides. So we need the opposite and the hypotenuse if we're going to use sine. We need the adjacent and the hypotenuse if we're going to use cos, and we need the opposite and the adjacent if we're going to use tan. Now when I look at my diagram, straight away I can see I know the adjacent side. That's the length of this side here. It is 550 meters. So I can tick A wherever I see it in my triangles. Then when I look again, I can see I don't know the hypotenuse, and it doesn't appear that I can work it out at all. So I need to know the opposite. And then when I look, I do have 2 measurements here, 1.6 meters, the height of this person, and 324 meters, the height of the Eiffel Tower. So I can work out the length of this opposite side quite easily by doing 324, take away 1.6. So I'm just going to write that down. The opposite side is 324, take away 1.6. And that's going to give me 322.4. Take away the 1, 323. Take away the 0.6, 322.4 meters. So I'm going to write that next to my O on my diagram, like so. So that's 322.4. Now I know my opposite. I can tick O in my triangles as well. And then clearly, when you look at the 3 triangles, the formula I need to use is going to be tan. It's the one that I know both sides in, or the one with 2 ticks. Okay, remember how we use these triangles to help us get the answer is to cover up the thing we are working out. So we want to work out the angle, so that's associated with tan, so you cover up T. So that reveals opposite over adjacent. So T, which stands for tan, of the angle, and this, they've used the label theta, often used to represent an angle, it's a Greek letter, equals O over A, opposite divided by adjacent. Okay, so I always write the formula first before I substitute any values in, before I plug my numbers in. Okay, now I can plug my numbers in. I know the opposite because I just worked it out, 322.4, and I know the adjacent because I was given 550. Now my next step is to actually work that out as a decimal. Okay, it's a fraction because the top is smaller than the bottom, so I know that's a proper fraction, so it's going to be 0 point something before I even use the calculator. I'm just going to move that out to give me a bit more space. I'm going to pop to my calculator. Okay, so there we have it, 322.4 divided by 550, and we get 0.58618 recurring. That's what that line means on this calculator. So it means 18181818 forever. I'm not going to round at the moment. I'm going to put that in 0.58618. We'd use 2 dots normally when we write it on page. I'm just going to check the answer again. 0.58618 recurring. Okay, now what I need to do is the opposite of tan. Now before I use the calculator to do that, this is what I would want you to write this down. This says the tan of theta equals 0.58618 recurring. Obviously this is not my angle. You're not going to have an angle 0.5 degrees. This is the tan of my angle is 0.58618 recurring degrees. I want to know what theta is on its own. Now to get rid of tan, just like any equation really, you do the opposite. And the opposite of tan is tan minus 1. Inverse tan. And it's tan minus 1 in the calculator. I need to do that at both sides. It would cancel out the tan there, leaving theta, but then I need to write it in front of my value, because this is what I need to do on the calculator. Move this up. Go to the calculator, and I need to do inverse tan of that. So if I do tan minus 1, if I clear this, if I do tan minus 1 of, I'm going to write in 322.4 divided by 550, and I get instantly, as you can see here, it's a huge number, it's 30.378. I don't need the rest, 30.378. .378, and we normally round angles to 1 decimal place. And here's our answer. Now there's one thing I need to point out. When I used my calculator there and used tan minus 1 of 322.4 divided by 550, you could have typed in 0.586181818181818, or left it on your screen. But when you do that, you've got to make sure your calculator is in degrees. And you can see at the top of my calculator I have DEG, short for degrees, because the angle is in degrees that we're working out. You could have radians and gradients. So if you see rad or grad, or you see a little r or a little g, you need to change that until it says D or deg, short for degrees. Okay, to quickly recap then, we label the sides first, write our SOHCAHTOA in our triangles, tick the sides we're given, work out any sides that we might need that are not obviously given straight away. Then the formula, the triangle with 2 ticks is the formula we need. In this case it was tan. Always write the formula first. Plug in any numbers. Change that to a decimal. Then you need to do the inverse tan, or if it was cos, you would do inverse cos. If it was tan, sine, you do inverse sine of the value you get. And that gives you your angle. And that looks more reasonable now, around 30 degrees. Round it to 1 decimal place, because that's what we typically do for angles. Thank you very much.